All right, this is a word problem review of Chapter 2. So these are the word problems that we've covered in Chapter 2. You have consecutive integers. We have the translation problems, the value problems, coins and stamps, and I think we did some tickets. We also have the investment problems, and then the uniform motion problems. So let's go over all of these just fairly quickly. So what we're going to do is just form equations and not solve them. So the first one says, find three consecutive odd integers such that the sum of the first 2 times the second and 3 times the third is 70. Now this is a little more complicated than you're going to see on any of your tests, but it is a good problem. That's why we have it here. So with each of these problems, if you notice, they all start with right in terms of x, right in terms of x, right in terms of x. This is the proper form to start any word problem. No matter what method you use out there, they're all going to start with defining your quantities, listing what's given in that problem. And what we're doing is basically listing what's the unknown. So we're looking for the first integer, second integer, and the third integer. And if you remember from our notes, the first one's x, the second one is x plus 2, and the third is x plus 4. Because with any odd integer, they are always going to be 2 away. So to create the next integer, you would take your first one and then add 2. And then take that number again and add 4. So if you notice, if this was 1, you add 2 and you get 3. You add 4 and you get 5. So this will create any integer that you want. So like if we had 3, 3 plus 2 is 5, 3 plus 4 is 7. Works every time. And then we're just going to translate this. So it says the sum of the first, so our first would be x, and sum means add. So for all these little commas, we're just adding. And then it says 2 times the second plus 3 times the third is 70. So anytime you see a translation like this, you want to just translate it word by word straight across. So you end up with x plus 2 times x plus 2 plus 3 times x plus 4, and that equals 70. All right, let's try the next one now. It says a bicycle and a bicycle helmet cost $240. How much did each cost? If the bicycle cost, there it is again, the bicycle is our translation. So the bicycle cost 5 times as much as the helmet. So we call the helmet h. And like I said, writing in terms of x, this is where we want to always start. So since I said x, we got to replace our h with an x, which would mean the helmet is x and the bicycle is 5x. Once you have this, it really is just going back and plugging in like we did before. So it says the bicycle, that was x, 5x, and the helmet, that was h. So these two have to add up to 240. So your equation becomes 5x plus x equals 240. So once you define these, the rest becomes nice and quick and clean. It also gives you a location to plug it in. So if we got, for an answer, if we get it for our answer x is 7, then we would know that's 7, and that's 5 times 7. It also tells us our answer. So let's say the cost of the bicycle is 35. Cost of a helmet is 7. It's not 7 because we didn't actually solve it, but there you go. Coins. So solving these, the way we set them up is this one has been given a total. And some of them will have translations like this as well, where it'll say the number of nickels is 5 times as many as the number of dimes. And so that would become 5x and x, just like before. But this one gave us a total. So with totals, you make one x. It doesn't matter which one, and the other one is what's left. And then once you have that, it is strictly plugging it in. We are dealing with nickels. What's the value of a nickel? It's 5 cents. And there are x of them. What's the value of a dime? 10 cents. And there are 27 minus x of them. And this has a total value of 225. You can also put decimals in there and it'll work the same. So our equation becomes 5x plus 10, 27 minus x equals 225. And that's how you do every single value problem. So this right here will never change. All it changes is the value. You could have lizards and turtles. A lizard's worth $5 and a turtle's worth $10. It would be the exact same problem. Investments. So investments, the translation part was the description for our variables is right here. We're always looking for the principal for the account 1 and principal for account 2. So this is where your variables will go, right in there. So you just fill it in. It says a total of 9,000 was invested. So our total principal is 9,000. And the interest rate, you do have to change these to decimals. Be 0.10 and 0.12. And then the total interest will also always be given right there, 1,030. So now this is the same problem as this, except this one is dealing with investing and this one's dealing with coins. It's 27 coins. This is $9,000. So you make one of them X, the other is 9,000 minus X. And then if we multiply, because it's principal times rate, will give you your interest. 0.10x, 0.12 times 9,000 minus X. And that last column is your equation. So we're just comparing interest. The interest from the first account plus the interest from the second account has to be 1,030. All right, last type we have, these are our uniform motion problems. And they work the same way. The only difference here is it's either the rate that's going to get the variables or the time. So when we do any of these, you want to start with a picture. So it says a passenger train and a freight train start towards each other at the same time from 2 points 300 miles apart. So this is 300 miles apart, and they are traveling towards each other. This is going to be our equation. So it's saying here that this distance plus this distance would have to be this distance. So the distance traveled by the passenger train plus the distance traveled by the freight train would have to be 300. So it says if the rate of the passenger train exceeds the rate of, there's our translation again. So it says the rate of the passenger train, that's the one we want. So we'll call this one the passenger, and this one is the freight. So the passenger exceeds the rate of the freight train by 15. So exceeds means addition. So we're saying our freight train plus 15. So our passenger is X plus 15, which means this one has to be just plain old X, which means the times are given. They have to be because we only get one variable in each of these. It says they meet after 4 hours. So that would be 4 and 4. And just like if you've noticed, we've done on every single one except for these because these are just straight translations. But it's a quantity and a value. Each time we're multiplying some principal and a rate, a value and a number. Here it's a rate and a time. So when you multiply them, you get 4, X plus 15, and then 4X. And so we'll make this one the freight train. That one's 4X. And this one is the distance traveled by the passenger. So this right here is the distance of the passenger. Right there. So that's how far the passenger train traveled. This one is the distance for the freight. That's how far the freight traveled. And if you notice, this distance plus this distance has to be 300. So it forms our equation for us. The other one that we had in our notes and in our problems is when the distances are the same. And that would be the exact same setup. However, the picture would look like this, or it would be like this, but their distances are still the same. They form the equation. So whatever's on the top is equal to whatever's on the bottom. The top is equal to the bottom. Top is equal to the bottom. So if you had these, you can look back at the notes, you would see that the equation would just be equal. So you would be saying this one equals this one. But in this problem, this one plus this one is equal to 300. This is why I want you to be drawing a picture. And on your exams, all of this stuff will be there exactly how it looks right now. You still have to solve the equation, of course, but it's going to be the exact same way. You have to define the variables. You have to form the equation because that's algebra. Algebra is setting this stuff up, and it should start to seem very, very simple. And if it doesn't, you got more practice to do. These take a lot of practice, but they will click, and I need you to see the similarities between every single one. It shouldn't just be how do I do this problem, but it's how do I set up a word problem. It's always the same thing, right, in terms of x. So you're listing everything that it's giving you, and then you're using that information and its relationship to form an equation. So we know from the problem it says all of that. So like here, the bicycle helmet and the bicycle, they both have to cost $240. So the cost of the bike and the cost of the helmet has to add up to $240. So if your descriptions are always good, it really does help making it. The more time you spend in setting it up, the less time these problems will take you. And they're going to be less confusing as well. So that's it. I hope this makes a little bit more sense for you. But no matter what, they take a lot of practice. All right.